Concentration loss is a prevalent issue for many people and can decrease productivity greatly, especially for students. Hence, we are proposing an EEG-based BCI that can track and alert user when there is a concentration loss. We are tracking concentration level by monitoring a common indicator of focus, which is the beta wave. Then, when the user starts losing focus, our device will send a real-time haptic feedback, which is a small vibration in order to alert the user to stay focused. Our goal is not only to help users maintain their focus and increase productivity, but also empower them with self-awareness and self-regulation. In addition, thanks to the device user-friendly and non-invasive nature, it can be used in a variety of settings and for various users with various needs.
Hi, so our project uses the Open BCI wet electrode EEG in order to stream brain frequency data to us in real time through 10 electrodes. So since we're trying to measure student concentration and focus during study sessions, our electrode placement focuses on two main regions, with the first one being the prefrontal cortex as well as the frontal, occipital, and parietal lobes. And so what we're specifically looking for in these recordings are the difference between the alpha and beta waves as well as the band powers. And so the way we originally defined concentration was through our initial recordings using the Open BCI focus widget. And so what this does is basically just tell us when the user is focused versus when they are not. And so the way we used this was going into our recordings to see when the user was focused, and from there we could generate our own threshold based on the average of the band powers. Now I'm going to be talking a little bit about our data streaming. So we use the Python library MNE to visualize and analyze our data straight from the EEG itself. And so doing this, we can look at our recording and get rid of any noise by applying a low bandpass filter. And so since MNE doesn't work in real time, we also use the library called BrainFlow in order to process our data in real time, as well as work with our classifier.
Let's talk a little bit about the classification and processing aspect of our project. During our project, we wanted to see a good metric to be able to identify when a user is focused and when they are unfocused. So during our experimentation process, we saw that when a user is focused, these bands, the alpha waves, the beta waves, and the gamma rays, these specific bands start acting up very specifically. The beta wave band will always stay up on top, and the alpha and gamma waves would fluctuate very violently right next to it. And when the user is not focused, these three bands would fall down or act more fluctuatively, and we would not be able to find any kind of regular pattern with them. And that's when you can classify that the user is unfocused. So what we did is we decided to print out the raw values for these bands, which you can see over here. And we decided to create a threshold-based classifier that can identify when exactly these bands are up and when exactly these bands are down. So what our program that we wrote does is that it looks specifically at these three bands, and when the user is focused and the beta wave is high up and these two are fluctuating, it captures that and classifies that as focusing. And when these three things are going haywire, as when the user does when they're not focusing, then it classifies that as not focusing, which as you can see is represented right over here, and their corresponding values. As such, we're able to classify focus and unfocused user behavior, and our project works using that. Thank you very much.
All right. Yeah, so the way our program communicates with the Open BCI is using a dongle. The Cyton board is actually communicating directly with the dongle that transmits all the information through a program called BrainFlow into a Python program, analyzes all the system using PyQt5, and that communicates directly to the Arduino. We use a library called Arduino with our Python program that directly communicates with another piece of code called using the Arduino IDE. Go for it. Right, so as I was explaining earlier, our program basically starts with Python that we connect to a piece of Python code and a specific serial port that connects to the Cyton and the board ID. As soon as I run it, our GUI that we created ourselves would pop up, connecting directly to the Cyton board. This is what it looks like when none of the electrodes are connected. So it's just going to be raw sample data. It will fluctuate based on the stimulation to the electrode entry points right there. If you look right here, our Arduino is actually connected directly to the PC using a USB port. This is exactly the piece of code that we are using. for the Arduino, and this is the Python code that we're using. When we connect to the Arduino actually is consistent of two different parts. One part is the LCD and the buzzer. The LCD and buzzer both are connected by this specific area of the pin section, which is going from ground all the way back to pin 3. A lot of the connections are directly to the LCD, and there's specifically 3 connections to the buzzer, and the ground and power cords are right here. There is a ground that connects directly to this breadboard, which connects to a battery pack, and the information part of this breadboard is connected to this side of the pin board. Not much of the battery. It has its own separate battery component and special wiring that connects to the motor when the motor is attached. If you look right here, we could see that the Arduino code is a very simple code. It's a giant if-else loop, which basically is taking one piece of program, which is specifically that string. If that string is consistent of digital write 14.1, that means that the user is unfocused, and it would essentially print that. If it's not printing that, if the program is responding with a digital write 14.0, that means the user is focused and the LCD screen will adjust accordingly. The way that is actually given out is using this specific piece of classifier that analyzes the hertz between 15 and 35 in this case, and it sends digital 14.1 if the user is not focused, and digital write 14.0 if the user is focused. Thank you so much.
During the trial, when we used BCI in real time during a learning session, we aimed to have each learning session to be 10 minutes of reading or studying. For testing the classifier, we made sure the user was focused on the material, uninterrupted for 2 to 3 minutes, and then interrupted the focus by instructing them to look up and talk to someone. The program we used detected beta waves in the bound power and updated a counter, which will continue to increase until the user refocuses. We adjusted the counter for different users depending on how long they wanted to receive feedback. It would send a message to the Arduino to trigger a haptic motor, and the user would be alerted to refocus their attention on the material. By using the haptic feedback, the user can effectively refocus their attention on learning and continue to stay concentrated during their study session. Moving forward, we plan on testing the project on longer learning sessions to accurately detect the loss of focus. We would also like to test this with more students to see if the haptic feedback is the best notification system for telling the user to concentrate and refocus on the material.
Hi, so now we're going to be presenting our live demo for our project. So we have our subject here, Raj, and what he's going to be doing is he's going to be reading his textbook for about 2 minutes, and then we're going to have a third person come and interrupt him just by saying hi, getting him to look up. And so right now we have our electrodes placed on the head with our hardware right next to him. And so what we have in there is our Arduino and our haptic device, which will activate when he loses focus after a certain amount of time. Like we mentioned earlier, this is a time that can be adjusted based on the user. And we also have a fan which will operate when he is focused, and this was just something we added onto our project. And to the left of here, we have our classifier in the back, as well as the visualization of the data. So we can look at each electrode channel as it's going and the band powers that are being used. So now we will begin.
Hey Braj, how you doing, man?
Hey, pretty good, man. How's it going?
That's good. What are you studying something right
Yeah,
now?
yeah. I'm actually
Oh,
doing my
nice.
anatomy right now, studying for
wow.
the finals. Yeah.
Perfect.